Hello grade 12s. Today I'm looking at the question 2 of the 2016 final paper, the curve of interpenetration. So what have they given you here? They've given you the front view and the top view. Remember, this is in first angle with the graphic projection. They've got a circle as the main pipe and a triangle as the branch pipe. It has been tilted at an angle of 30 degrees. That's quite nice because it's easier to then project the points up onto the branch pipe and then take them down. Because we've got a circle here, what we need to remember is that because it's a circle, the lines joining the points in our front view to get the curve of interpenetration will be curved. They won't be straight lines. So they've asked you to complete the front view showing the curve of interpenetration, complete the top view, and develop the triangular duct. Okay, so we need to draw the given views for 4 marks. So I've started by drawing the circle for my top view. I've then constructed the triangle so that I can get this height measurement and the distance to the center here, which I can then mark off on my top view. So the key element here, I've projected the lowest line because that's where it's touching my circle. I'm going to get this vertical distance. Okay, it's not a sloping distance. I need this vertical distance, which I can then just mark off on this line, which gives me the highest point of my triangle. Okay, so that gives me that width dimension that I'm going to need there. I'm now going to go up into the front view, complete the front view, where I can get these points, which I'll project back down to find where they are going to touch in this top view. So when we need to get the triangle distance here, remember that's the whole length of the triangle. So if we had constructed our triangle here, that would have been our shape more or less. So that distance is equal to the length of the base, which was 50. So on my line that I've projected here, I can mark off my distance of 50. And the center of that would obviously be at 25. So I can mark that off and project those lines down, and we'll get those to find our curve of interpenetration. Let's look at numbering of this shape. Once again, it's up to you how you want to do it, but let's say I'm going to start at this point here, 1, 2, and 3. Now, where would we get those points in the front view? Now, the lowest point in the front view would be this point. Okay, because we can see by this shape here. So it would make this point 2 and this edge 2. This edge is on the same line, making this point 3. And if we followed that down, that point 3. This is the middle point, which is the middle point 1. Okay. So that's what we would be doing. So if we take this into our shape here, there is 2, there is 1, there is 3. So 2, let's project that one down. 2 has got to be this top edge here. Here is point 1, this is the lowest edge. Here is point 3, and that's in line with point 2. Okay, so there are our points that we need to join up to make our top view complete. Let's find the easy points now, the actual points on our triangle. What do we need to remember? Well, at this edge of our main pipe, anything behind that's going to be hidden detail, meaning the only point that we're going to see is point 1. So that one's going to be quite easy. Why? Well, point 1, we're going to project a line down to where it hits the circle. It hits the circle at the middle of the circle, and if we follow that point up, there is point 1 lining up with point 1 from our vertical line. Now if we find point 2 and 3, point 2 and 3 hit at the same point, so we're going to project that up. This is where point 2 hits, this is where point 3 hits. Remember, these are going to be hidden detail, they're behind the shape. So those are the easy points that we found. We've now got to find the other points along our shape here. So what is the problem with that? Well, we need to find a point on the circle, project that to hit our branch pipe. Because our branch pipe is tilted, we can take those up to where they hit the branch pipe and parallel down to where they hit the vertical line to give us our points. So with our circle, the next step is going to put in pizza slices. I've put in our center lines we've got, and now our pizza slices. Here is point 1, which we found already. Here is A, B, C, D, and point 2 and 3 we've already found. So let's work through these steps one at a time. So I'm finding point A now. So I've projected horizontally from my circle to hit the branch pipe. Remember, this works when the branch pipe is tilted. We then projected the points up to give out 2 points in the front view, and I now project down parallel to my branch pipe to cut my vertical line A, and that gives me those 2 points A in the front view. We're going to follow the same process with point B. Get used to trying to follow the same process. So I've projected my vertical line now into my front view from point B. I've projected my lines to cut the branch pipe. Where they cut the branch pipe, project them up to cut the edge of the branch pipe in our front view, and project it down now parallel to come back down and hit point B at the vertical line. Okay, so those give us our 2 point B. Our next point is C, so this is the last point that is visible. So we've already got the vertical line projected, so projected my horizontal line to where it cuts the branch pipe, project that up into the branch pipe in the front view, and project that down to cut our point on the edge of our shape. So that is what I can join up now. That is the visible aspect. So there we have the outline of the branch pipe with the points that we can see. So point 1, A, B, C. Now let's find other points. remembering that from point C, these points at the back here, so point D and 2 and 3, will be in hidden detail. Now we've already found points 2 and point 3, so the last point for us to find is point D, and we need to follow the same process that we've used to find the other points. So from point D, we're going to project our line vertically, then we're going to project our line to cut the branch pipe. Where it cuts the branch pipe, we project the points up to touch the branch pipe in our front view. Then we follow those points down to our D line with D and B. Okay, so there's our D, and same on this side. There's our point D. So on the inside here, point 2 to 3 joins up in a straight line from C through D and back in hidden detail, and this little edge in hidden detail for the bottom and the top of the triangle. So there we've got our branch pipe triangle. There goes 3 to where point 3 touches. At the edge of our circle, it's behind the shapes in hidden detail. Here is point 1 of the triangle, the line darkened here. Point 2 of the triangle darkened, hidden detail from the edge of the circle to where point 2 is. That hidden detail that we needed to draw in now was where C went to D and then to 2. Very hard to try and get that shape curved. And the same at the top of the shape. There we have the curve of interpenetration in the front view and the completed top view of our branch pipe and main pipe. Now they've asked us to develop the triangle. So I'm going to take that triangle shape and flip it down here and get what we need. So what I've done is I've just projected from the base of my front view. I've left a space of 15 millimeters to give me my edge. I've reconstructed my auxiliary view of the triangular prism. Why? Because I'm going to need to take the measurements off there. So at this point here, we need to mark off the edges of our triangle. Okay, so we know it's the length of 50. You could have just marked that off with your ruler. I'm going to just take my compass, set my distance to that 50 and mark it off. So you get our 3 edges. It's up to you which side you want to label with, start with. I'm going to maybe pick my edge there and mark those off. Let's project in our vertical heights and find the easiest distances. So if we remember now, what we need to do is find the true height dimension, which we get in the front view. Okay, so the height is in the front view. So I'm going to take point 1, 2, 3, get the heights for those specific corners and mark them off on their corresponding developments. Here's height 3. Go to point 3 and mark that off. Here is point 1. and now point 2. And mark it off for height 2. So those are the easy heights. They're on the actual lines of our triangular prism, so that shouldn't be too hard to work out. Now we need to go and get the measurements in the top view for our pizza slices, which we need to take across to our auxiliary view to get what the true length will be. So we're going to start with point A. I've projected point A to cut my auxiliary view. I now need to take that little measurement and transfer it to my development. Now this is a very tiny measurement from 1 to A, so what I'm going to do is actually work the other way and take the bigger distance. So there's the distance from 2 to point A, which will be the same as 3 to point A. So let's mark that off. So first of all, I'm going to point 2 to mark towards corner 1 to get point A on this side. Then I'm going to go to point 3 and mark towards point 1 to get A on the other side. And project that vertical line in. And we need to get the height dimension from our front view. So in the front view, we go and find where point A is. Now here is 1 going to 3. 1 going to 3. So at that point we need this measurement. There's 1. So here is 1 going to point 3. That's where I need to mark this height off. On the other side, here is point 1. And this is where 1 is going to point 2. Slightly longer that distance. And mark it off on the side. So we finally point B, pizza slice B, I've projected to my auxiliary view. Now once again we can go from point 1 and mark it in. The distance is still a bit small, so I'm still going to go from corner 2, get the distance. Corner 2 would give me the same distance as corner 3. So go to corner 3, mark it towards 1. This is going to give me point B. At point 2, do the same thing, going back towards corner 1, and there is point B. We're going to mark our vertical lines now and find the height measurement in the front view. So let's go to find point B. Here is point B. Remember, here is corner 1 going to corner 3. So here is our distance to B. Remember, 1 going to 3. So here's 1 going to point 3, and we need to mark this height off vertically. There's the height at B. Now on the other side, we've got 1 going to point 2. So at point B, take our distance at point B. As you can see there, it's a little bit longer. Come and mark that off. Next, step 3, or point 3. I've projected point C to cut our auxiliary view. I'm following the same process. I'm taking my corner from 1 to C, and I'm going to now transfer that. So I've measured from 1 this time. So there's my distance from 1 to find point C, 1 to find point C, and I'm going to draw in my vertical line. Now when it's going from 1 to point 3, I need this C measurement. So there I'm taking that C measurement. I'm going to 1 to part 3. At the C there, I mark off that C height. Follow that process. Here is point C, where 1 goes to 2. Get my distance. Then look at the correct measurement here. Here's 1 to 2, and there's C, and I mark off my height measurement there. Last point is pizza slice D. Let's follow the same process. I've measured my distance from 1 to D now, after drawing it across. So put my compass at 1, mark off. Put my compass at 1 on the other side and mark it off. There gives me my points D. Let's draw in the vertical lines. I've drawn in my vertical lines and I now need my measurements. So here is 1 going to 3, and there is the height that I need. Come to point D on this side where it's 1 going to 3. There is my height measurement. At the bottom of the shape, this is 1 going to 2, and here is the height that I need for D. Come where 1 goes to 2, and at that D I can mark off my height. Here we've got the curve. Part 2 and 3 is going to be a straight line coming from 2 to 3, and the curve on the side. And there we have the completed top view, the front view with showing the curve of interpenetration and our development of the triangular branch pipe. Remember, on the branch pipe, the edges where the folds were would be an outline.